mute yourselves. Please mute yourselves. And if you have any trouble with connectivity, we found that also turning off your video will boost your connectivity. So we welcome Judi DiMaio, who is a wonderful volunteer here, a board member, and she says a self-acclaimed weather geek since she was a kid. And she's keeps learning and growing in her weather skills. I've had a chance to look at the outline of her presentation today, and we're in for a treat. So welcome, Judi. We're delighted that you're doing this presentation. There will be time afterwards for questions, but if you want to put something in the chat in the meantime, Laurel and I will be monitoring it. So Judi, I'll turn it over to you.
Okay, thank you. All right, can everybody see my screen?
We sure can.
Okay, so I will start. Today we're going to talk about dynamic weather or weather basics. And it's something like Kathy said, that I've been interested in since I was a kid. And you can learn an awful lot from the weather. And I'm not sure why my screen is not moving. There we go. Okay, so the first thing we're going to do, and it's entirely up to you, is I just have a quick quiz, whether it's true or false. You can just keep it to yourself and write down what you think. And then when we go through the presentation, you'll find out if you were right or not. Lightning can be a bolt out of the blue. Crickets can tell the temperature. Hurricanes in the northern hemisphere, which is where we are, rotate counterclockwise. Mare's tails and mackerel skies are a real thing dealing with weather. Snowflakes have 8 sides, and your car's rubber tires protect you from lightning strikes. So you can think about what you think, and we'll find out later on. So first of all, what is weather? Something that everybody talks about. It's one of the few things that affects everybody on the planet. It's the most talked about subject and one of the least understood. So the easiest way to understand what weather is just it's a bunch of events that happen in our atmosphere on a daily basis. So what is the difference between weather and climate? All climate is a weather pattern that's measured over a long time, like several decades. So weather and health. Why is knowing about the weather important? Well, you can predict it by observing, and we'll be talking a lot more about that later, that you too can learn to predict the weather without a fancy computer. It lets you know how to dress most of the time, especially if you work at the WOC, you want to be prepared. You want to know the health problems it can cause, whether it's hot or cold weather issues such as heat stroke, hypothermia, etc. Know what situations might come out of it. For example, I think a lot of people in New Jersey finally understand what flash flooding is. After we had Ida, a lot of people don't understand flash flooding because New Jersey typically doesn't have a lot of it. Especially if you spend a lot of time outdoors or in remote places, it's very good to understand what's going on with the weather. And by the way, this is just going to be a complete overview. We're not going to go into a lot of depth about anything or physics or things like that. So there are 5 layers to the atmosphere. The one that's most important is the troposphere, the one toward the bottom. That's where most of our weather is. Then you have the ozone layer, the stratosphere, and the rest of them. So what causes weather? Well, it's called uneven heating by the sun. The sun heats the air from the poles to the equator. As you know, the equator gets more sun. And the uneven heating, even on surfaces, the uneven heating causes the air to move, and which causes the air masses to move into each other, which causes clouds and precipitation. To kind of envision this, imagine a fish tank, say a 10-gallon fish tank. You fill it with water, and then you've got a little heater on one side. If you put some dye into it, you'll see the heat, the warm water goes up, moves across the tank, cools off, sinks, and goes back, and the cycle repeats itself. It's called convection. That's what causes weather. Weather consists of things like air temperature, air pressure, wind speed and direction, And the important thing to understand about that is if you ever hear, for example, northwest wind at 6, it's not the direction it's blowing to, it's the direction it's blowing from. So that's important to remember. Precipitation, relative humidity, clouds visibility, and dew point. Just going to talk quickly about temperature. It's basically measured in 2 scales, depending which side of the Atlantic you're on. We use Fahrenheit, and it's important because temperature affects most of our lives. We're going to react differently if it's going to be 95 and humid versus if it's going to be 30. So then you have the wind. So what causes the wind? Again, it comes back to the uneven sun heating and the movement of air masses. And you've got low pressure, because air masses, you can have high pressure, you can have low pressure. And they're usually next to each other. They tend to alternate. And the greater the difference in the pressure, the stronger the winds. The way I like to think about it is think about if you've ever had the pleasure of going on a subway in New York City. You walk in, it's a really crowded car. Well, what you want to do is you want to go to a car with less people. Molecules in the air do the same thing. They want to go from high pressure to lower pressure. The other thing about wind is, again, it's from the difference between high pressure and low pressure systems. And the only thing I want to show you here is if you look, L obviously stands for low. And if you can see, it rotates counterclockwise. Next, and it's red. Next is a blue H for a high pressure system. And if you notice, that rotates clockwise. And we're going to talk a little bit about maps later. So these black lines you see are called isobars. And within them is how the wind speed is and the pressure. So the closer they are, the higher the wind. You can kind of think of them if you've ever looked at a topographical map where you have altitudes. This does the same thing with pressure, but we'll talk a little more about them later. Everybody's heard of prevailing winds, and without going into great detail, depending on the Earth's rotation and something called the Coriolis effect, winds will go across the globe in different ways. If you can look where the United States is, you see the arrows are pointing west to east because most of our weather comes from the west. You also have air pressure. And what is that? That's the weight of the atmosphere pushing down on the Earth's surface. It's just like if anybody dives, just like water. You know, the further down you go, the more pressure you can feel. It's reliable for forecasting weather. And because air masses move and pressure changes in reliable patterns, it's not really haphazard. And pressure dropping usually indicates bad weather approaching. It also decreases, the pressure decreases as altitude increases. And usually it's about 3.5 degrees decrease for each 1,000 feet. Now, if we're going to talk a little bit about low pressure systems, they rotate counterclockwise in the northern hemisphere, which you can see in the picture on the left. It's counterclockwise. And again, that usually means bad weather is approaching. If you look at the right picture, that's in the southern hemisphere, and you can see it rotates clockwise. Now, I went to Australia, and this intrigued me. Now, so Australia is, of course, in the southern hemisphere. So the first thing that I did is I filled up the sink to let the water out because I wanted to see which way it went down the drain. And it does go backwards from up here. So I thought that was interesting. This is Hurricane Katrina. It's just a close-up of a low pressure system. Your classic hurricane textbook, you can see it rotates toward the left counterclockwise. And the eye of the hurricane, the stronger the storm, the lower the pressure, the higher the winds, which is the stronger the storm. But the interesting thing is, if you could see down the eye of the hurricane, you would see the ocean because it goes all the way down. And for those of you that have never been inside a hurricane, this is the inside eye wall of Hurricane Katrina from a hurricane hunter. If you can see, there's blue sky, the sun is out, the weather is perfect. The eye wall is perfectly calm. How did you get that picture? Because I actually pay people to fly through hurricanes, which is really kind of crazy, but they do. They know how to do it. They do certain patterns. They fly in certain ways, certain areas, and they drop sensors, and you can see one right there below the plane. And then the sensors collect all the information which is how we get the updates on the hurricanes. So high pressure systems usually means fair weather is coming because the descending air is usually warmer and drier. Now fronts, I'm sure you've heard of fronts, cold fronts, warm fronts. All a front is a transition zone between different air masses. And we're just going to talk about 3 different kinds: cold fronts, warm fronts, and stationary fronts. Cold fronts move quickly. The air is pushed into the warm air. Again, they usually alternate. And when cold fronts pass, the weather can change dramatically. The temperature can drop suddenly, winds can gust, and rain can fall. And if you've ever been outside, I'm sure you've noticed at least once, wow, it feels like the wind picked up, it's getting chilly. What do most people say? Well, it's going to rain, right? And warm fronts move a lot slower. Warm air pushes into cold air, and it often brings stormy weather. The way I remember how fast they move is if you're cold, you're trying to move around and keep yourself warm, whereas actually if you're warm, you don't feel like moving. You're just kind of slow sitting there. So the fronts are the same way. A stationary front is just merely when a cold or warm front stops moving. One of them isn't strong to move the other one, so they just kind of sit there. They can sit there for days while they try to decide what they want to do. Sometimes if the wind direction changes, they'll move. Sometimes it's a stalemate, they just break apart. But the boundary between the two of them, there is a boundary, there is a difference. So the wind and the temperature are different on both sides. And the weather is often cloudy with precipitation. So sometimes if you get those days that kind of seem like this, that just it rains for like 3 days, that's probably because there's a stationary front. And one of the things that you're going to learn if you want to learn how to predict weather is clouds typically come in a certain fashion before each kind of front. So this will show you that. So before the warm front, and we're going to talk about clouds later, so don't worry about all the different names of the clouds. This is a warm front, so you get rainfall that's light to moderate, steady or intermittent, and remember they move slow, so it's 12 to 15 knots. And you can see the Cirrus clouds, those high wispy ones, can be as far out as 1,000 miles. So this isn't something where you get all the clouds in the next 5 minutes. And if you learn these patterns, eventually you'll be able to predict things. Now for a cold front, it's kind of almost the same thing. Certain clouds come through in a certain pattern, and you get moderate to heavy showers. And if you notice, they're almost twice as fast. And you all know what a squall line is. That's that gusty wind with the storms. It can be 50 to 100 miles ahead of the front. So you can see these Cirrus clouds are out about 200 miles. I'm going to talk a little bit about precipitation, which you're all familiar with. There's different types: rain, which of course everybody knows; sleet, which is partially melted ice, which only falls in the winter; and my favorite, which is hail. Hail is composed of ice or a mix of ice and snow, but it can fall at any season, usually with severe weather. In fact, most of the time you hear about hail, you hear about it in the summer. It can be up to 5 inches or more in diameter, which is really pretty amazing. But how does hail form? Well, without getting too technical, remember I said the temperature decreases with height. So you all know, you're all familiar with the Cumulonimbus cloud. They're those big cumulus clouds that bring the storms. Well, they can be over 60,000 feet high. So it's pretty cold up there. So what happens is you get these poor raindrops, and there's updrafts and downdrafts, by the way. Air is going up and down in the storms. So you get the raindrops that fall down, get to the updrafts, get way up to where it's cold and freeze. And this cycle repeats a whole bunch of times, each time with the raindrop, which is now ice, getting bigger and bigger and bigger. The stronger the storm, the stronger the updraft, the more times the little raindrop will go up and down until eventually it gets too big and too heavy and it falls out as hail. And the one thing I want to interject here is, once I retire, I plan on moving out of state. Wyoming is one place I was thinking of going until I saw this. Wyoming is known for its storms and hailstorms. Now, this is some serious hail from a supercell, and it can cause a lot of damage. That's not a hard ball, by the way, that she's holding. That's a softball. And that's typical hail sizes. So hail can be pretty big and pretty destructive. So I decided that the Great Plains was probably not someplace I wanted to live. You also have snow. There's all different types of snow, which forms hexagonal crystals, which means it's six-sided. No two snowflakes are the same, which I think is really incredible. I'd love to know how they figure that out. When anytime it snows, there's like trillions and trillions and zillions of snow crystals everywhere. And 10 inches of snow equals 1 inch of rain, which got me thinking that when Ida came through, we had 11 inches of rain. So I said to myself, wow, if this was colder, I don't know how many feet that is, but that would be 110 inches of snow and I'd still be digging out. So that was pretty incredible. So I'm just glad that we had Ida when it was warm and not cold. And dew is just when water vapor condenses on objects near the ground because there's no clouds to keep the heat in, so it radiates. And then of course we have our wise adult here. This is nothing. When I was your age, the snow was up to my neck. As a kid kind of goes, yeah, I can see that. And without going into detail, there's all different types of snow. It depends on the temperature. The colder it is, also the less likely snow is to form. And I know this is in centigrade, so just for reference, minus 10 degrees is about 14 degrees Fahrenheit, and minus 20 is about minus 4 degrees Fahrenheit. So you can see the different shapes based on the temperature. In fact, once it gets to 20 degrees Fahrenheit and lower, it's harder and harder to snow because the air is so dry. You also have frost, which is basically dew that freezes when it's below 32 degrees and water vapor changes into a solid. Now we're going to talk about one of my favorite things, and I think one of the most obvious about weather, which is clouds. Clouds can form anywhere from the ground to 60,000 feet, and there's a lot of different types. And you can also learn to forecast weather reliably from observing clouds. Now, before I start, I just want to mention, like I said, there's a lot of different subtypes of clouds. And you don't have to worry about that now because there's 3 main types. This is almost kind of like when you first decided you wanted to start watching birds, butterflies, plants, trees, whatever it is when you first started, and you couldn't tell, and I'm just going to use birds, where you couldn't tell a duck from a robin almost. So what's the first thing you do? You don't go looking for warblers, you look into groups like, oh, okay, you got these guys that are in the water, then you got these big birds that kind of soar, and you got these little guys like that are in my yard. So you kind of break it up into general categories. And the more you observe and the more you learn, the more you can break it down. So for example, like Cirrus clouds could be just like ducks. There's a lot of different types of ducks, but they all look the same, basically, with just slight differences. So don't be overwhelmed if we talk later about a couple different types of clouds. That'll come if you're interested with more observation. But basically, based on their shape, there are 3 types of clouds. Cirrus clouds, which are your thin, feathery, wispy clouds. That's Latin for curl. Cumulus clouds, which are your fluffy clouds, the cotton ball type things, which is Latin for heap or pile. Stratus, which are your layered clouds, which is Latin for layer, or your clouds are just kind of like meh. Like today, at least here, you can't even see the sky. It's just like this dull overcast. Those are stratus clouds. So how do you name them? Well, you combine the name of the cloud shape and the cloud's height, and we'll talk about that in a second. And nimbus just means rain. So if you say cumulonimbus, it's a cumulus cloud that's going to rain. And there's just high, mid, and lower level clouds. The high ones get the name alto. Think of a voice in a choir. Mid-level is strato, and if it's lower, it's just their plain name. So here's just an example of some clouds. And you can see from the picture, even like the stratocumulus, they still look puffy. The cumulus, the alto cumulus, and they're still like puffy. You can still tell that they're cumulus clouds. They're slightly different shapes. But so you can see what I mean. As long as you have the basic shapes down, that's a start. You don't have to worry about all the other stuff unless you're really interested and you want to pursue it. So we're going to talk first about cirrus clouds, which are my personal favorite. They're high-level clouds, usually above 20,000 feet, and they're composed of ice crystals, which is important in some of the stuff I'll show you. They have a very wispy white appearance and generally occur in fair weather. This is why they're cool. Because they're made out of ice crystals, they can reflect the sun at different angles, forming things like the picture on the left is called sundogs and other optical phenomena, where that looks like there's two full suns, one on each side. And then sometimes you see rainbow effects. That's just reflecting off the ice crystals. You've got, these are called glories, the way that looks on the left, halos, and that can happen around the moon too, with the ice crystals. So you have Stratus Clouds. Again, don't worry about the difference. They're wispy, they're very transparent. And Cirrocumulus are small white puffy clouds. This is why I like Cirrus Clouds. That is just so pretty. They're just really cool. They have a lot of cool things that they can do. Nimbus Clouds, Nimbus is Latin for rain. These are your lower clouds. They usually form at 7,000 to 15,000 feet. They have a steady precipitation, and as the clouds thicken, the base is lowered to the ground. So on the example on the left is just nimbostratus, which is kind of like what we have today. Again, just a blah, all just gray cloud. And then on the right is the Cumulonimbus, or the big storm cloud that everybody's familiar with in the summer. Cumulus clouds are cool because they show vertical growth. They can be white puffy cotton balls of different sizes, and how high they get depends on the humidity in the air. And tops of the clouds can exceed 60,000 feet. So they can actually grow into towering cumulus. We call those cumulus congestus from the heating of the day. And the really cool thing is you can actually watch them expand vertically. It's almost kind of like if you've ever used that expansion foam in the house, you can actually watch them grow. So if conditions are favorable and growth continues, you end up with your supercells. And they can end up with very violent thunderstorms and form anvil formations. Now these are the anvils, but you're looking at them from underneath. If you were to look at it from above, which is taken from an airplane, you can actually see the anvil shape. Stratus clouds, like I said, are for blanket or layer. They're fairly featureless. And when they reach the ground, they're called fog. And fog can also lift from the ground to form stratus clouds. These are just a few more examples. Like I said, they're just kind of nondescript. And then some of your high clouds, your alto cumulus, could mean an afternoon summer thunderstorm. Alto stratus usually could mean continuous precipitation when it covers most of the sky. It also allows for pretty cool looking sunsets. I don't know if anybody's ever seen these. This is Mount Ranier. They're called lenticular clouds, and they form a certain way, but only around mountains. There's some more. People have reported them as UFOs. In fact, the first UFO ever reported was actually a lenticular cloud in Alaska. You also have things called crepuscular rays, which looks really cool. But for this to happen, there has to be enough dust or haze in the air. And even though it looks different from us, those rays are actually parallel. We just can't see it because of something called perception. Like when you look down the railroad tracks, it looks wide to you, but then it gets narrower and narrower. Light pillars are another cool phenomena. Usually you see them around sunset. It kind of looks like somebody's holding a spotlight up. And that all again has to do with the stuff in the air and how the sunlight reflects off it. These are really, really cool, and they're very rarely seen. And that's just caused because you have two layers of air, one's moving faster than the other. And they actually look like waves in the water. Mackeral clouds, I'm sure people have heard of, because it looks like the sides of a mackerel, the striping on a mackerel. This is a roll cloud. They can go on for miles. Warm air rolls over cold air, and it kind of just rolls horizontally. Sometimes they come in front of thunderstorms, but they don't always mean bad weather. And the aurora, of course, really isn't a cloud, but it's just really cool. It's when the sun's particles, because it's always emitting particles, enter and interact with our atmosphere and our magnetic field. And that's what causes the waviness. They're usually green, but from time to time, you can see other colors. And this is really cool. I've only seen this once in my life, and you really need to be someplace like down the shore. Just before the sun sets, you see a little green flash, which lasts only a second or two. If you're ever down the shore, take a look for it. It's kind of cool. These are called Mammatocumulus Clouds, which look really weird. They're actually like upside down clouds, and they usually hang down, and they usually hang down from the Cumulonimbus Clouds, our friend, the storm cloud. And sometimes, but not always, it can mean severe weather's on the way. And then I have my own group that I just call nasty clouds. This was in Chicago. This brought a really nasty thunderstorm behind it. This is out in the Midwest. This is trying to form a tornado. Right now, you've got a lot of heavy rain coming down from the downdraft. This is a shelf cloud. It's kind of like a roll cloud, but this one is attached to a thunderstorm and generally brings bad weather. This I tried to put up here. I hope you can see it on your screen as much as I can. I don't know if you noticed the color. It's a greenish gray color. And I don't know if you've ever heard, for those of you who's ever lived like in the Midwest or Texas, sometimes before you get a really bad storm, you get this really weird greenish gray color in the sky. That's kind of what it looks like. And this is one of my favorites. This is why I don't live in the Midwest. This is a supercell, that's a downburst, and it's getting ready to lower a tornado. And just for scale, I don't know if you can see it. That thing on the right-hand side is a very big tree and a barn. And then about a third of the way over, I don't know if you can see, there's a tiny little dot, which is a house. So that's just for scale. To me, this looks apocalyptic. How interesting are clouds? Interesting enough for the post office to make stamps out of them way back when it was 37 cents. Now for a supercell thunderstorm, I'm not going to go into details about it, but you can see on the bottom the tornado. You can see the anvil up top, and you can see the up and down drafts that carries the rain up and down. But what I wanted to show you was the radar. I'm sure you've all seen radar on TV. If you ever look at it, they call it look for the hook. And you can kind of see it on here where the red is rolling back around. That's usually a radar indicated tornado. So in case you're ever looking at radar, you can look for the hook. I certainly hope those people aren't home. And does New Jersey get tornadoes? Yes, we do. We've even gotten some EF3s lately, which is different from New Jersey. These are just different pictures of the tornadoes that we had back in September. So if you have storms, you have lightning, which is what? Just an electrical spark between the clouds, the air, and the ground. The same thing as if you rub your feet on the rug and go to touch a doorknob. It's just a very, very large static electricity. It can heat the air around it to 5 times the temperature of the surface of the sun, which is pretty warm. Most common is cloud to ground, even though there's cloud to cloud, ground to cloud, cloud to air. Lightning can strike up to 16 miles from a storm under a blue sky. So yes, the bolt of a blue, it does happen. The lightning will go horizontally, and then at some point, the difference in charge, something will attract it and it will come down. When lightning strikes, you can see on the golf course, it makes these really kind of cool looking patterns. And yes, planes often get hit by lightning, but their electronics usually can handle it. So a lot of people wonder what happens if your car gets struck by lightning? What saves you? It's not your tires. It's the metal on the car. The lightning strikes the car, the frame, travels around the outside of the vehicle, and then enters the ground like it's grounded. This will not work in a golf cart, and it will not work in a convertible. And basically, there's just a lot of positive and negative charges, both in the clouds and the ground, and opposites attract. So if there's something very tall on the ground that has a negative charge and a positive charge from the cloud, guess what? That's how you get your lightning strike. So lightning safety is important. How safe are you indoors? A lot of people don't realize there are some things you shouldn't do. Don't use corded phones. Cellular phones or cordless phones are okay. Don't touch electrical equipment such as computers, TVs, anything that's plugged in. Again, remote control things are okay. Avoid plumbing. Don't wash your hands, take a shower, or wash dishes. Why? Because if lightning hits, pipes are metal and it can actually come through water because water is a conductor as well. Stay away from windows and doors, stay off porches. You don't want to lie on concrete floors or lean against concrete walls. And of course, if you have dogs and pets, you don't want to leave them outside. So what about if you're outside and you can't get indoors? Stay away from water and wet items. Water conducts electricity. Stay away from isolated trees or other tall objects. Metal fences. I've seen people lose cattle because lightning hits a fence and they're within close range. And again, when lightning strikes, even the ground, it spreads out. It doesn't just stop there. It can spread 20 or more feet. So if you're on a bike, pull over. If you're on a boat, drop the anchor and get as low as you can. And obviously, if you're playing sports outside, get inside. Avoid the dugout, get in your vehicle or a restroom. So what is thunder? Well, lightning gets the air really hot, really fast, and it explodes outwards. That shock wave is what we call thunder. It's like heating a kernel of popcorn really high, really fast, how it explodes. Thunder can be heard 25 miles away from lightning. And you can count how far it is. All you have to do is count the seconds from the flash until you hear the thunder, divide by 5 for miles, because sound travels about 1/5 of a mile per second. And some people say there's heat lightning. All heat lightning is regular lightning from a regular storm, but you're just too far away to hear the thunder. I want to talk a few seconds about rainbows. I know everybody's seen rainbows, but have you really ever looked at one? For example, if this picture wasn't there, would you know what color is on top? Right? Red is on top. And the reason we get rainbows is because everybody knows what a prism is. White light goes through and comes out in all different colors. Each raindrop acts like a prism. So you get all those different colors because the light is reflected through the raindrop. Sometimes, as in this picture, you can get a double rainbow, and it's fainter because that means the light has to be reflected twice through the raindrop. But the interesting thing is, next time you see a double rainbow, look at the color on top. It's opposite. So on the bottom rainbow, red is the top color. On the secondary rainbow, red is the underneath color. I'm just going to talk really quick about a weather map in case you ever see one so you know what you're looking at. This might be a typical weather map. H stands for high, L, and they're always blue. L stands for a low pressure system. I don't know if you can see the black lines. Those are the isobars. And if you see numbers that are underlined, which are not always on there, that's the pressure. And then you see these blue and red lines. If you look at the one coming down from Canada, there's a low, you can see a bunch of blue triangles pointing to the right. Blue is a cold front, and the triangles are pointing to the right, so that's the way it's moving. Up on top of that, there's a bunch of red half circles. That's a warm front, and that's moving up. If you see them when they're mixed, like on the bottom in the Gulf of Mexico, you've got both red and blue. That's called the stationary front. That's the one we talked about before. So that's basically a weather map. And remember with the isobars, those lines, the closer they are, the stronger the winds. So forecasting the weather, meteorologists use a lot of complicated data, complicated computer systems, and a lot of work. You too, though, can learn to predict the weather reasonably well without a fancy computer. And if you're interested, the best way to start is to begin to notice your weather patterns day by day. There's a few general things to work with. Air pressure, you can look at a barometer. Higher rising air pressure, the air is pretty stable. Lower falling pressure, the air is moving up from the land into the atmosphere, which indicates unstable or changing weather. You can use your barometer to monitor this, or your arthritis, as some claim. Some people say they get headaches. Clouds, different clouds can indicate different things, as we talked about earlier, and there's certain patterns for when a front is approaching. Start to notice which way the wind blows and what weather follows. Look for patterns. And I'm not going to go through all of these, but once you learn the different types of clouds, you can see, like, for example, if you have cumulus, that's those puffy clouds with no vertical development. In other words, they're just cotton puffs. You're going to have nice weather. And if you look, cumulonimbus, that's our rainstorm cloud. You'll have thunderstorms very soon. So different clouds can indicate different things. And we also have some old wives' tales that I'm sure you've all heard of. How many have heard of red sky at night, sailor's delight, red sky in morning, sailor's fair warning? Do you ever wonder if those are true or false? Well, this one is true most of the time, because for there to be red sky, the first thing you have to have is dust or haze in the air. And that usually occurs in dry air. So if you have red sky in the morning, that means you're looking east. And that means the dry air is already past you and the wet air is coming. That's why if it's red sky at night, it's already past you. Clear moon, frost soon. That's true too. Once there's no clouds, the heat escapes, and if it's cold enough, you'll soon get frost. The picture we saw earlier was halo around the sun or moon, rain or snow soon. Yup, because the halos are cirrus clouds with the ice crystals. And those are actually cirrostratus clouds, and they usually indicate an approaching warm front, which has to do with precipitation. How about when the wind is out of the east, is neither good for man nor beast. Somebody mentioned this earlier. When it's out of the east, it's a typical nor'easter. And every nor'easter I know either brings a lot of snow or some nasty weather. Excuse me. And then we have some other things. Some people say that your cup of coffee can predict the weather. Now, you're supposed to have a little bit of cream in your coffee. Some people swear by this, some people say no. But they say when bubbles of coffee collect in the center of the cup, expect fair weather. When they adhere to the cup, forming a ring, expect rain. If the bubbles separate without taking a fixed position, the weather will be changeable. Up to you. You might want to try it. Some people say it works. Some people say it doesn't. But I do know you have to have some kind of creamer in it. Nature also helps. A lot of times in this day and age, we've lost touch with nature. And there are a lot of things that you can observe that help you forecast the weather. Some bird calls, including crows and geese, become more frequent with a falling barometer. And falling pressure also affects cows, what are called ruminants, deer and elk, making them less likely to go out to pasture and eat. They usually lie down. And I grew up on a farm, and I remember my aunt always telling me that, look, the cows are laying down. It's going to be raining pretty soon. And I live out in a farm area, and I see that a lot. So I tend to kind of believe that one. You also have some flowers that close up as the humidity increases, so rain won't wash their pollen away. Some trees, most notably oak and maple, curl or turn inside out just before a storm. I don't know if you've ever noticed that. They're actually inside out. Church bells sound different depending on how humid the air is. The higher the humidity, the better sound travels, so the louder and different a church bell will sound. Cicadas can't vibrate their wings in high humidity. So typically they're quiet as rain approaches. I don't remember when we had all our millions of friends here, but that's what they say. And there's one of them under an umbrella there. Flying insects are generally more active and stay closer to the ground when the pressure drops. But what about crickets? Can crickets foretell the weather? They can tell the temperature. They can actually do this. If you count the number of chirps in 14 seconds, then add 40. And interestingly, almost 80% of the time, the number will be within 1 degree of the actual temperature. I think that's pretty amazing. I've tried it when I hear crickets at home, and it seems to work for me. So I think that's pretty interesting. And then I just want to end with 2 little poems. When the sky is red in the morning and sound travels far at night, when fish jump high from the water and flies stick tight and bite, when you can't get salt from your shaker and your corn gives you extra pain, there's no need to consult an almanac. You just know it's going to rain. And since I have a couple friends who are weathermen, this is for them. Ode to the weatherman. In the dying embers, these are my main regrets. When I'm right, no one remembers, but when I'm wrong, no one forgets. So now we had our quick quiz at the beginning, if you answered. So can lightning be a bolt out of the blue? Yes, it sure can, up to 16 miles away. Crickets can tell the temperature. Hurricanes do rotate counterclockwise in the northern hemisphere. Mare's tails and mackerel skies are a real thing, clouds that deal with weather. Snowflakes have 6 sides, not 8, and it's not your car's rubber tires that protect you from lightning strikes. So that's really all I have. So I don't know if there's any questions, but I
Judi,
guess.
Judi, that was phenomenal. Thank you very, very much.
Thank you.
And I learned a lot. I'm sure people have some questions. So
let me just stop. You want me to stop sharing my screen if I can figure out how to do that?
Yes, I think that would be helpful.
Okay.
But Judi, that was terrific. Thank you.
Well, thank you. Like I said, weather's one of those things you can talk about things for hours.
Well, we're going to have you again.
Yes, yes. So I didn't see anything in the chat, but if someone would like to ask a question, feel free to put it in the chat, or unmute yourself and ask the question. Looks like Bridget's going to ask a question.
Well, I wasn't going to, but since you called on me, okay, this is just a throwaway. Fairly recently in my book group, we read Isaac's Storm.
Okay.
So, Judi, I would, have you read that book?
No, I have not.
You might enjoy it. It's about the Galveston.
Oh, thank you.
Yeah. It's written by Eric Larson. So he's a very good writer. Yeah, and there's a lot of I'm getting feedback on here. That's okay.
Thank you.
So we read that in our book group as well. And it is a fantastic book.
Well, one of the other reasons I wanted to talk about the weather is a lot of people sit outside of the WOC. I think everybody's getting feedback now from somewhere.
So if you would keep yourself muted until you have a question, that will help. Someone else with a question. Okay.
Nice rainbow picture, whoever had that.
So Paul Lauber came from the Big Sit, and so he has a question.
Yeah, Judi, great presentation. Thanks a lot.
Thank you.
Quick question. I spent a lot of time at the Rock. I know you do too. And I go over to New Providence, and I always notice my car, like the temperature is cooler in the Great Swamp than just a few miles away. Could you speak to what happens and why that might be the case?
Well, there's different elevations to start with, because what I like to do is I look at the temperature in my car, and you have to have it running for a while because it will be different. Like if you just, especially on a hot day, if you just get in your car and you turn it on, mine says like 104, and you know it's not 104. You have to run it for a while. But elevation and environment make a difference. What I like to do is get in my car, look at the temperature as I exit the parking lot, and then by the time I get home, it's about 8 degrees, either warmer or cooler. Because the swamp is so low, the cooler air tends to condense. We have a lot of water. And you're probably, I don't know what your topography is by you, but we'll tend to stay warmer or cooler once, like when the sun absorbs on all the water that we have, or the grass. And it depends on elevation and how much sun and everything else.
Okay, thanks. And one other question. When I was a kid, I remember they talked about the wind chill factor all the time.
Yep.
Now they talk about the real feel. Is there a difference? Do you know why they would change that terminology?
It sounds friendlier.
Okay.
It sounds a lot friendlier. I had a wind chill picture, I took it out because people don't realize, even on, like say a 60-degree day, if you get a high enough wind, the temperature really drops. And the reason I always like to bring it up is because, and I wish I had that picture now, but I don't. And I always tell people that it's really important. They don't think about it on a warm day, but I said, imagine yourself on a motorcycle, right? And even let's say it's 60 and you're doing 60 miles an hour. It doesn't feel like 60, it feels like 35. So wind chill, and it also depends if you're wet or not. As you know, if you're wet, you get colder quicker. So wind chill is important to keep in mind, especially if you're going to be outdoors, like at the WOC.
Great, thanks.
Anyone else?
I have a question.
Sure. Hi, Dot.
Yeah, hi. Great program. I'm looking forward to going through the recording. I learned a lot. But my question is, could you explain what dew point means a little bit? I've never been able to get my head around dew point.
Okay. This is going to be interesting because I have to explain relative humidity in order to explain dew point. The first thing I want to say is more and more radio stations and weather people are going toward dew point, because the dew point is not temperature dependent. Dew point is the point at which water condenses out of the atmosphere when you get dew, okay? So that's pretty reliable. In fact, when you have dew points that are in the 50s up to 60, it feels very comfortable. Once you start to getting around 60, you start to notice it. Anything around 65, you start feeling really sticky. Anything over 65 into the 70s, you're gonna feel like you're down in the Gulf of Mexico. And that's because that's the temperature at which the water is condensing out of the air, which is why you feel so sticky. And that's why if you hang clothes out, they won't dry. The reason they want to use dew point is because that's fairly consistent. Relative humidity, everybody talks about the humidity, but that's temperature dependent and it's not as reliable. And here's the example I use. Warm air holds more water than cold air, okay? Cold air does not hold as much moisture as warm air. So far, so good? Let's take a jar that's 16 ounces, okay? That's gonna be our warm air. Now let's take another jar that's only 8 ounces. That's gonna be our cold air, okay? So let's go back to the big jar, the warm air. It's 16 ounces. I put 8 ounces of water in the 16-ounce jar. What percent of that jar is filled? 50%, right? Half of it. Relative humidity is measured in percent. So this warm air has 50% humidity because it can hold 16 ounces, but it's only holding 8. So it's got 50% humidity. Now let's go to the little jar, the cold air. And if I put 4 ounces of water in the 8-ounce jar, what percent is that jar full? 50%. So in both cases, the relative humidity is 50%, but there's a different amount of water in the air. Right. It doesn't give you as much. That's why it's called relative humidity. It's how much how much water is in the air relative to how much it can hold. So if you say 50% humidity, that doesn't mean anything if you don't know what the temperature is. That's why more and more weathermen are going to the dew point. I hope that made sense.
Yes, yes, yes. Yep, yep. I will go for 50% dew point.
Yes. And the
So,
interesting
Judy,
thing is, if the temperature and dew point are within 5 degrees of each other, expect dew and or fog. You can amaze your friends.
Oh, okay.
so if it's raining, does that mean it's 100% humidity?
Could be.
Could be.
Because yeah, most of the time it is.
Thank you. Yeah. Anyone else with a question or a comment? I love Tom Ostrand's weather picture.
Yeah, the rainbow, right?
Yes, yes. Good virtual background. Good picture, Tom.
Yes. And if anybody's interested further, I'll be happy to talk weather, or if they want to learn different things like how to observe or what to look for. Because it really isn't hard. I think I mentioned this before, to learn how to observe and just go out. Did I mention the class?
Not yet. I'd love if you talk about that.
Okay. I just finished a short class through Harvard online, and I love the teacher we had, because what he was saying is, I can teach anyone weather, I can teach anyone meteorology, but unless you can use it, it's useless. He spends a lot of time outdoors. So his whole thing was learn the basics, kind of like I just taught you, but be able to apply it. In other words, if you spend a lot of time outdoors or in remote areas, you may not be able to get a signal or listen to the radio. So you really do need to know what's going on around you. And what he had us do which is very easy to do, again, if you're interested, is twice a week. We'd have to go out twice a day with no instruments and guess the temperature, humidity, dew point, wind, speed and direction, and then later on the clouds. And then write it down, submit it, and then look in the newspaper or and see how close we were. The longer we did that, the closer we got, and you noticed more. So it's really interesting what you can do without even instruments. And when the Coast Guard teaches their weather class, what they expect you to do is, without instruments, accurately predict the weather 18 to 36 hours ahead of time. So it can be done. So if anybody's interested, I'll be happy to talk weather with anybody.
Is this program going to be on the website somewhere? This recording, today's program was recorded, and is it going to go on the Friends website?
It will be up at some point on the Friends YouTube channel.
YouTube. Okay.
I'm not sure if and Laurel, if you want to jump in, I'm not sure if we'll be editing, how much editing it will take. Maybe Laurel's saying not much. So 2 days it will be up, Laurel?
So I would say within a couple of days, and I'll put it in the next happenings with a link to it, but you can search the Friends YouTube channel by doing Friends of Great Swamp NWR YouTube. And there are a number of other videos up there as well, including our photo contest awards ceremony, which was held last weekend.
So Judi, thank you for agreeing that we could tape this, because record it, because people are interested. And be sure you look at the photo contest winner video. That's wonderful also.
It is. It was very well done.
It was.
So the winner's gallery, the winning photos, is on the Friends website. What's on YouTube is the 40-minute awards ceremony, which was a lot of fun, but it is a little bit longer.
Yeah.
And Kathy, can I just say before
Sure.
we end, you should say again, because it was not recorded, that this is hosted by the Friends and Marta Heflin.
Yes, so we get support from the Marta Heflin Foundation and also from our wonderful Friends group. So we thank both of them. And we will in November, Jim Mulvey will be talking about eagles. So Tom Ostrand, did you have a question?
Yeah, could I go back to dew point for a moment? Would that be okay?
Sure.
So what I understood you to say is, so dew point does not depend on temperature. Is that correct?
That's what they say.
Okay, but on the other hand, it's the temperature at which
Point. They say the point. They deliberately.
The point at which moisture will condense. But isn't that in fact dependent on temperature? I mean, if you have warm temperature, if the air is warmer, it can hold more moisture and therefore less likely to condense. Isn't that right?
I understand where you're coming from. But when I asked my professor, because I had always been confused about that, what they're trying to go for is, I guess, how it feels on the skin. I don't have a better answer for you. I can look it up, because the only definitions I could even find, I was looking for a simpler way to explain it, was just the point at which the moisture condenses into the air. That was it. And I remember both looking it up, and my instructors were saying it's not temperature dependent, like relative humidity is. So apparently, like the 50% relative humidity, we showed how different percent could be. According to this, point is 7.5, then it's 7.5. Again, I can get back to the clarification on that.
Okay. Certainly would appreciate it. Whatever you can say, whatever you can tell. Thank you. Kathy, you're talking, but you're muted. So I don't think anyone can hear you.
You are right. I thought I hit the button and I had not. So any other questions or comments for the good of the order? I'm glad we all got together this afternoon. This was a wonderful way to spend a rainy afternoon. A phenomenal presentation, Judi.
Thank you.
And we look forward to seeing you at the Refuge, and come out and try out those agents of discovery. Bring yourself around and bring your young friends along to show you how to use the program. And it's a lot of people have put a lot of work into the program, so come check it out. And it's great. Yeah, it's great to see Steve.
Yes.
Here from North Carolina. So, so thank you.
Thank you, everyone. Thank you, Judi.
You're welcome.
So long.
Okay, bye.
Thank you very much, Steve.